Hello everybody, my name's Frankie V and I am one of the content creators at Frozen Sand working on Urban Terror HD, and recently we've been discussing and talking about doing how-to type videos for those of you out there who are interested in making content for Urban Terror HD, particularly in the area of map making. Which is, is still an open playing field for anybody who wishes to participate in the arts and craft section, or or by being able to develop third-party maps, which has always been, a kind of cornerstone that has made Urban Terror popular over the years. Now, in this particular episode of How To, we're going to cover some ideas how we can use 3ds Max to quickly create terrain objects. Particularly in the area of boxing in or creating a holder for the kind of maps that you want to kind of plunk something into without worrying about things like players getting up on the edge of a wall and being able to look over the edge and see the bottom of the skybox. That's not really too cool, and a lack of detail necessary to make things a little bit more towards the kind of HD quality that we want to see. So starting off with the idea of being able to create the terrain, there's a lot of different ways or different ideas or different approaches that you can do or use to be able to create the necessary surface area and topology in specific areas of interest. So say for example this courtyard in here, we want a lumpy and bumpy surface area that looks like this area here has had a lack of maintenance and so forth. And by using this particular technique, you can kind of expand the idea into various different areas. And as an example, let me show off something that Rabid Cow, one of our geniuses on the team here, has taken this technique and more or less created a soft deformed topology using tile texturing to keep the budgets low and so forth. So once you've built what you need, you can use various different ways to be able to slice things up to be able to conform to the requirements of the engine, and not particularly stick to these type of ideas that I'll be presenting, because I'm going to be throwing due to my development style, I more or less like to build what I want and want to see first, and then of course tailor things down detail-wise to what is necessary to make it a fitting object by design. That way, my theory is you always start big and then work small, which is a lot easier to do than trying to make something that's not enough more. So by going to, say, the dark side and making things a little bit more excessive, you have the wiggle room to make things less and still maintain the overall quality of the final result. So that's what we're going to be doing here. Is we're going to be looking at more or less bucketing in my map I'm working on here, 2 towers, so that players who manage to get into areas of the map where they can actually look over the edge are not looking into infrastructure, say for example in this case the skybox. And to begin with, we need to discuss a little bit about topology in general. Now, in nature, things are round, curvy, shapely, and has a much more continuity in the deformation of the surface area, which is not something you can really obtain or maintain by the use of quad surfaces or polygon modeling. As to the nature of it is, of course, it's a square versus the necessary tessellation of the surface area to create much more smoother soft body objects. So to start off, getting into the nuts and bolts of things, a good first approach would be to create a representation of the overall volume of the area that we want to cover with our terrain by creating a spline shape, in this case a rectangle, that is relative in scale to the kind of surface area that we want to cover. and instead of working in this area and this area and this area, we're going to do everything in one big chunk and onto a single sheet of polygons, or in this case faces, as you will quickly see the difference here. Now with our rectangle shape selected, I'm going to go over to our modifier panel here, and I am going to select Garment Maker, which is used to make garments, of course, as soft cloth dynamics. But what is nice about the surface area here is the type of topology that you get is based on tris rather than a polygonal surface, which allows it to deform in more or less in three directions, which is rather than two directions, which is the natural tendency of a polygon surface. So we can stretch, pull, and push what we want into the various different directions that we want our terrain to move into. Okay, so with that kind of selected here, what I'm going to do at this juncture is to do a hold. Now, there is a nastiness to a garment surface in that the amount of surface area that can be created is based on the overall volume of the surface area that is created itself. So since this is covering a much larger area, I'm pretty sure I could probably play around with the values to get it down to what I want it to. We land up with an initial base of 1,264 polygons. Now, unfortunately, that's probably going to be a little bit too much. So let's see if we can actually get that down a little bit by decreasing the amount of surface or increasing the amount of surface area that we want to create in the first place based on the overall volume of our map. So let's try that again. Sometimes the value changes, sometimes it doesn't. Strange things also happen when you are actually doing screen recordings, or still maybe a little too high. Okay, we'll just carry on from here, and once again we'll just go ahead and do a save or a hold, so we can do a fetch if things tend to explode. Now, a word of caution here: we can increase or decrease the amount of densities of the surface area that we need. Obviously, we need to increase it to allow for the kind of deformation that we want of our terrain. But the density value can get really nasty if you don't, if you treat it with any kind of level of disrespect. In other words, if we're looking over here and go, okay, we need our topology to be a little bit more. In this case, I'm going to change our color here to something that's a little bit more visible. We want to change our topology here to add a little bit more. Obviously, we need to, as per the scaling of the map itself, we need more. So we need to increase our density. But if you you kind of click the spinner here. Be aware that the mesh density that is increased is by a factor of each time by a factor of 0.01, by a factor of 0.001, which will literally basically double the amount of surface, or even triple the amount of surface area that you have, or even so far as 10 times more if you go oopsie and you make this density 1. You're going to land up with a surface amount of topology that's something like 500,000 to maybe even 1 million. But basically your computer is going to explode long before it's able to achieve that amount of detail. So be very careful about the value changes over here. Do not click on the spinner, because you are going to more or less cause your computer to explode. Well, I'm not speaking literally, of course, for those who actually believe those kind of things. And we're going to start with small values. So in this example here, let's start off with a value of 0.0202. So you can see that dramatically the number of polygons have jumped up to 14K. Now, overall, taking in consideration the amount of surface area that we're going to be covering, that's not really a bad value at all. It's a good starting point, and I'll be showing you some optimization techniques to be able to bring that down to something a little bit more reasonable. After all, we don't want to be wasting surface area that's not necessary to maintain shape if we don't have to. Okay, so always be thinking in those terms of being able to decrease things down to a lot more reasonable level, rather than get it rather abusive by saying, well, 14K, no big deal. Okay, so anyways, carrying on here. Another word of warning: be really careful about how you use your mouse at this point, because as part of a selection, if we were to actually use our wheelie here, we'll be increasing our value here, and things will explode. So be sure to exit out of any changes that can be made to this before you start messing around with anything in the viewport. So now we can use the wheelie here and move in and out. If I had done this, 10 million, 20 million. So So anyways, we have enough surface area here to get the kind of desired results that we want, and we can kind of move things into a much more better position here. You know, we want to kind of move things below the planar of the expected amount of volume that we want. We want to be able to have a little bit more wiggle room so we can push things around. And once we got that into place, let's go ahead and lock our changes in by converting things over to an editable poly, so we don't have to worry about Garment Maker doing strange things on us anymore. Might want a little bit more here or there. You know, you're going to probably be doing this, this process maybe 3 or 4 times to get the kind of volume that we want to create equal to both sides of the map. I'm in a realistic mode here, so let's turn that off because it is a performance hinder when it comes to editing surface area. Come on. There we go. Let's just go to strictly shaded mode so we don't get any shading effects, which is going to slow down our edits a bit. And let's just keep trying to balance things out so we have equal amount of surface on both sides. You know, that's looking pretty good. And let's let this juncture here, since we're locked in, let's go ahead and do a hold. So we always have to be the ability and the means to be able to go back to our base edit quickly and easily as we progress. Now, convert it over to an editable poly. First thing you want to do is any changes that we're going to be doing is going to be based on a sub-object selection. In other words, you have to have the particular object selected for it to be able to be included as part of this process. So, be it faces or vertices, I usually find that vertices deform a lot better by doing things based on face sub-object selection. What we're going to do now is simply go down into our rollout. Let's hide that. And go to feature in our editable poly set here, which is the paint deformation tool. Now, as all good 3D artists, let's switch over to my graphics tablet here, because as it says, it is paint deformation. Just to kind of restate once again, you do not have to restrict yourself to this process or procedure. If you find that if you're doing a particular area, that you can just throw on a deformation map onto it. That will do the job for you. Throw on some tiling, something like this type of idea. Was simply derived from this technique here, using texture maps to create the final result. Which, of course, if you take a look at it, it's a lot more smoother. There's a lot more continuity than you would probably ever get trying to get this kind of detail and sloping in using quads or polygons. In this case, this type of tessellation really works well for soft body object creation in general. So, if you can probably create things like rocks and outcrops and different types of more natural, realistic by using this technique in general. So don't focus on the fact that I'm creating a bucket for my map to sit into over and above some of the techniques that are being demonstrated here. Just want you to be aware of that. That's the creative nature of 3ds Max, is you do not have to do what I tell you to do. Okay, so anyways, carry on here. What we want to do now is to establish a value for our push-pull here. As you can see, we select push-pull. You can see our brush down here, based on the overall volume and scaling of our terrain here, is just microscopic and is scalable to the screen size that we were currently using. So we obviously need a much larger brush. So let's zoom that up. We take another look at it. You can see, even at this value, our brush size is way too small. So we now know that we need to really go big. And we're still too small, so we're talking about a brush size that exceeds 1,000 units so far. Now we get up to 2,000 units. Maybe that's a little too much. We'll bring that back down again to have a kind of a brush that's going to cover most of the exterior surfaces in a blanket type of effect. Now we need to actually determine the amount of overall strength we want, because at this value here, you're going to be doing a lot of this for a long time. So we want to up our push value in proximity to the overall size of our brush. So let's see what we got here. Still not enough, so we're probably looking at a value of closer to 200 before we're actually going to start getting the kind of control that we want. Okay, let's go just a touch more. Okay, so now if we do a bead, you can see that things are starting to pull out. a little bit more evenly. We do not want to use too much strength because we want to have a little bit more control over the evenness of how things start to extrude out from the surface area, as well as we, obviously we want to play around with brush values, in which case, you can play around with your brush options here, creating different types of curves to get more cliffy type of shapes versus things that are a little bit more rounded. And this is by far the ultimate form of control over creating the type of terrain that you want. And particularly in this case, something that is filling a much larger area than, say, something that can be easily accomplished by just using a texture map. So anyways, let's just go ahead and zoom around the exterior of our map a little bit. We just wanted enough at this juncture to be able to prevent the players from actually looking over the edge of our map, seeing our skybox. We're not going to be too much concerned about where a lot of this information is going. And once we have kind of established a kind of a base, remember, even sitting up here, it's going to, you're not going to be able to really see over that edge, even if it's a flat surface. So we can create roadways and so forth, just to kind of, once again, to kind of act as a mask. So once we got our bucket kind of semi filled in, we can start looking for ways to being able to add detail to our terrain here, in the form of say a semi-mountain range. Now, what I found is also if we put our map into a bucket, then the skybox itself creates, in conjunction between the terrain and the skybox, we create kind of a really nice parallax type of effect where the skybox becomes a little bit more natural in its movement based on covering the or trying to hide the bottom of our skybox in this manner. Okay, so now we can obviously we want to be we can, if we wanted to, start working on some detailing here by refining our overall strength of our brush, lumpy, bumpy mountain range. Just to kind of cover things in, and I've already built a pretty good terrain a bucket for my for two towers here that's already done, which I'm going to put in some detailed models across the top here, like maybe some light posts, create a kind of sense of a road being up here, put in some power lines, and just to kind of create a much putting on objects that creates a much better parallax between my box here, my bucket, and the skybox. So you can certainly spend a fair amount of time. We can even create more terrain on the outside here to kind of create a layer type of outwards type of effect. So ultimately, the skybox just simply becomes a sky, without any natural details in it, because all of it's been created in geometry. Okay, so anyways, we have somewhat of our bucket filled here. And of course, well, let's get a little bit more over here. You can certainly spend a lot of time doing and redoing, and because of the speed of how this works, you can afford to basically do a couple of tests to get the kind of feel of the direction that you want to start pulling things. And here things are kind of a little bit messy and pulled in. So to kind of demonstrate here, we can go into negative values, which is going to push our geometry in the opposite direction of the face normal. Okay, so let's increase our negative brush strength, so things will start to scale out a little bit faster. But in this process, of course, you can see how things are starting to stretch out a little bit. And you need to be careful about that. I'm not going to worry too much about what's going on along this ledge here. As long as we have enough surface that ducks in underneath it. Push things back a little bit. Be sure to decrease the brush size, because remember, it is projection based, so it can actually cause a rather unusual deformation in the surface area. We want to kind of make sure that we are protecting. I know here, for example, I have some additional geometry that goes in this area that acts as an insert. So we're pretty well below the surface plane there. The surface area in the back here, probably want a little bit more volume in that area, in the form of say some interesting geometry. Okay, now we're just playing art, doing the art, then demonstrating a technique here. Some interesting terrain by volume. In all probability you won't see this area, but you also have to kind of keep in mind the continuity of how objects are interconnected with one another, because you can inadvertently create a line of sight that is going to show infrastructure which you probably don't want to happen. You don't want somebody to see the actual detailing of the skybox outside of what it was intended as part of the overall design. Okay, so we have like a roadway there that we can have. It's an area here. It's kind of a wasted area. I don't really know what to put in there, so we'll include that as part of our detailing here. Okay, we're 21 minutes in, so we're pretty well in the ballpark. This could be say kind of a waterway. Then once again, we want to be able to kind of equalize things out a bit here, because we've done some pretty rather aggressive editing to our surface area here. That's more or less kind of distorted things a bit above and beyond what we want to be able to maintain the overall shape and form of the surface itself. So we're going to hit relax. We're going to set up our max strength. We need to do this through the print option, because we cannot increase the amount of brush strength that we have here without our paint options. You see, as I moved it, it put it back to 0. So let's up that, reselect relax, so we can go in here and quickly equalize our edge length. You'll know that you're equalized when your topology refuses to relax anymore. You brush over this a couple of times, you can see that the relaxed value, or the relaxing of the surface, is becoming less and less and less. So we're equalizing our topology here to make sure that we're getting a rather distortion-free and equalized surfaces between each of the face points here. Now, of course, we can spend a fair amount of time going over and over and over and brushing and brushing and brushing until we have the perfect distortion-free surface as far as geometry goes. But I think we're getting to the point where anything more than what we have now is just wasted tutorial time. Okay, so I think that's pretty good. For an all-in-one, let's build the forest first before we worry about the trees type of standpoint. Once again, the point here is that the topology itself just leads to a much more natural roll-off, regardless of what you're using. If you're using an image brush, for example, to create your terrain, and it's going to flow much more naturally rather than having hard edges, which is the natural tendency of polygon shapes. Okay, so anyways, 14K, obviously, probably in all probability a little too much. In most cases we want to make sure that we're optimizing for shape and form, and not necessarily having to maintain the amount of geometry within the geometry just for the sake of maintaining a form and shape. Now, there are optimization utilities, modifiers that can quickly decrease the amount of polygons to the count that you want, but I personally would rather do things a little bit more on the manual side of things, because I find that such modifiers, what they tend to do is to decrease the amount of faces as part of the object itself based on edge length, rather than something that should be a little bit more common sense, in that the proximity of a vertex from one vertex to another is what should be decreased. You should be decreasing the number of vertices, not the number of faces within the proximity to one another that doesn't support the overall shape or surface area. So something like this area back in here, for example, is really a non-viewable area. So a lot of this geometry here can go, and we can start creating flat siding, as long as the player who's standing up here can't see into this area. If they want to go no clip, then that's their problem. If they want to see the ugly part of parts of your map, but maintaining the players within the map, you obviously want to have your best looking stuff forward, and then sort of start chopping stuff up behind to decrease the amount of count down to something a little bit more efficient. But as a start to optimization, I like to decrease the number of vertices rather than trying to decrease the number of edge loops that are connected between one face and another. So let's select weld vertices, and as you can see, we have all our vertices selected still. The first thing I do is lock down the current selection by hitting the plus. And as you can see, before and after has no changes, since we have also our polycount tool up. We can kind of set up as triangles. It doesn't really matter if you have triangles or polygons set, because it's a trised surface anyways. So, but in this case, we'll just leave it at our count as triangles, and we want to start seeing this value decrease. But at the same time, by welding the proximity of one vertex between one vertex and another, which by keeping a visual track of what is actually occurring, and protecting various surface areas that we feel that is we've gone down as far as we want to go, by deselecting those areas and selecting various different areas that we want to decrease further. So overall, we want to begin with an overall conforming of this map down to a much more lower value. Okay, so we do that by just simply increasing the value of the spinner up. It's going to be a rather large value, but if you just go like this, for example, things will start to decrease at a rather exponential rate. So at about 56, we can see we still have the kind of surface retention or the surface shaping that we want to maintain, but we've obviously begun to decrease the amount of faces within our object. Okay, so we want to now lock down those values. If we hit the plus, difficult to explain. But if we continue to increase this decay of value, vertices start to collapse in on one another as they start to decrease in the amount of surface area that they maintain. So in this case, by going plus, we've basically more or less locked down the current and zeroed out the current values. So now things become a little bit more additive rather than progressive. So now if we go plus again, you can start to see that some of the surface area, well, just to kind of demonstrate it, let's go to a value that you can start to see that surface, we start to lose a lot of detail in our surface area. So if we control Z back to what value we have, we go up a little, we hit plus, we lock down our value. The values now become equalized as we start to decrease. We're watching the value up here. We probably want to get a little bit under 10K and lock down. Once again, watching the value changes. Now this could be a little bit time consuming, so I'm just going to show you more or less the basics, some of the basic things we can do to optimize this mesh down to say much more reasonable values, and at the same time watching and making sure that our surface area doesn't get all botched up. You can see, for example, here we have an edge that cuts across. We're going to clean that, but we're not going to worry too much about that right now. We'll clean that out later, a little bit later on down the road here, but we'll just go plus, and we'll continue to increase the amount of volume, the surface area. So you can see down here we're starting to get a little bit more five-way type of tessellation in our surface area rather than the three-way here. That's okay. It's still we can still maintain form and shape with that kind. But once again, it's what you see that matters, not so much what the numbers are telling you. So you just gotta kind of spin things around, hit plus. Okay, we're under 10,000. We can keep going on. Obviously based on selection. So for example, as I mentioned, we can select our selection tool. Let's get that out of the way. We can go to our selection tool here, go to our top view, Z, and we can select this area here, down here, which we can then use our spinner here to decrease the amount of volume in that specific area and still maintain overall shape. I also find that if you do a lot of rendering, it quickly tells you if you're starting to lose too much in the way of form, shape, and geometry. But for our example here, 9K is pretty good for the amount of area that we want to cover, versus this being a 9K object that well. For example, I have a water fountain in here that I have to still have to optimize, which is 25K, and it really doesn't affect frame rates at all. So 9K, a drop in the bucket, and we can work it and work it and work it until we ultimately get the result that we want. But I'm not about to do a 12-hour a 12-hour tutorial to fit the finish. We're just going to present some general ideas here to get the creative juices flowing. Okay, I'm going to call this done and done. And one last thing that we can do, exit out of that to even decrease further the amount of wasted geometry. Let me get my counter back up here again, just so we can kind of keep track of things. You always want to keep track of your count, because if things can get out of hand, particularly when you're modeling in a 3D application like 3ds Max, things can get out of hand rather quick. Okay, so basically we have a whole subsurface here that is not required. So we're going to just do a marquee selection of what's below there. Boom, gone, and boom, we're down to 7K of usable geometry, because we got rid of some surface area down below here that's not required. Kind of an optimization kind of thing. Now, in this case though, I'm going to put that back because it's going to really help us to kind of texture map this out. So based on the equalization features that some of the equalization features that are available in the UV mapping. Now, to get this kind of idea back into the mix, where you can use where are we? Oh, okay. Actually, I closed that window. If you remember back the example I showed you that Rabid Cow created of the flat surface containing tileable texture across the surface area, there are some techniques that we can use to create various different areas that are tileable. We certainly could take this entire map and tile it out if we wanted to. So keep that kind of thing in mind. I'll be demonstrating that a little bit more in detail, but for what we got here now, let's kind of isolate this out. Okay, we cannot isolate because I'm going to show you why. Oops. Hello. Didn't like that. See, things tend to explode on hide all. Okay, let's select that, and I'll show you why. Because everything in this scene is an X-reference scene, and each object is a separate object that makes up the total map itself. So all the different elements that make up this map are not actually in this scene, and there's still a lot more elements that make it up. But we no longer need it because we have our overall volume over space that we want to maintain. So we can just disable our references and then get this down to just being the texture map itself. So you can see that okay, we got terrain, and our map plops right down into the middle of it. So let's carry forward onto this and start talking a little bit about UV mapping. Now, this gets a little bit tricky because now you're getting in more into options, preferences, and so forth, about how somebody wants to be a little bit more conservative versus putting a lot more detail into the work. and try to keep things balanced out a little bit more budget-wise. Certainly at this juncture, if we wanted to, we can simply say, for example, well, let me pause here because I have a few things to set up here that behind the scenes that is just going to waste screen time that I forgot to set up beforehand. So give me a second, I'll be right back. Okay, I managed to find what I needed, and for our UV mapping part, and that's Blade Killer's top secret checkerboard texture. It's a real nice texture to be able to make sure that your texture maps or your UV mapping is distortion free, and it's probably one of the best out there, so I haven't bothered looking for anything else. And it has some key features in it that make sure that your texture maps aren't mirrored or overlapped or basically overly distorted. So now that we have our object set up here to begin with, upon creation, of course, this is automatically planar map. So let's just go ahead, throw on our texture map, and see what we have so far. So as you can see, we have a fair amount of distortion occurring within our map. But it's still not as bad as it could or would have been if we had used quads or polygon objects. We could spend a little bit more time to sort of balance things out a little bit more at this level by just selecting our sub objects and go back to push-pull, relaxing things a little bit more until things are a little bit more averaged out. But in this case, since this is a solid sheet, we don't what we're going to do is we're just going to go ahead and pelt map this to remove all of the distortion, and we'll select our UV mapping UV mapping tool here, bring up the display. You can see still a fair amount of geometry within our target area here, which will allow us to more or less map this out as a single sheet. So we select all our faces here, and we'll just go ahead and see if anything explodes by selecting the pelt mapping option and hit start pelt and see what happens to our surface area. So as you can see, we're not really getting the kind of efficient type of mapping that would be suitable, say, for tiling, but is more, say, fitting of a single skin surface, which in urban terror terms is rather wasteful, and be able to keep lower, I won't say quality, but say lower resolution type of textures, and then just simply tile it over it and do things to kind of hide the tiling effect. But anyways, at some point our pelting is going to stop on its own. For the sake of saving time here, I'm just going to pause things, and I'm just going to let the pelter continue to pelt things out until it stops on its own. Well, actually, as soon as I said that, of course, it stops. Okay, so now we have things pelted out here a little bit, and if we look at our texture map, things haven't changed because we have not commit these changes yet. But we can be reassured based on how it pulls things out that this ridge is pulled out based on the outer regions of our pulling strings here. So let's try relaxing things a little bit so that our edge faces become a little bit more equalized to one another. It doesn't necessarily have to match up identically with the topology of the map, but we want to be able to have our texture map to be distortion free, of course. Okay, let's see what's happened here so far. We'll hit stop, and we'll go ahead and just commit that to our surface. Of course, it's a little hard to see in the viewport, but you can see that let's decrease the overall size of this map so it fits within the target region, as if we were going to create a single UV mapped element. Now, if we were going to map this out using tiling, what we probably would want to do is to kind of get it into the target range, apply our tiling texture, and then increase the amount of UV mapping space that it takes so that proper tiling does occur. But for now, let's just kind of put everything into the target range here. Okay. Just remember, our texture will now take place within this volume of space as a single sheet texture, but anything outside this target area then becomes tileable. So we can then increase the scaling of our map proportionate to the tiling texture that we put on there, and actually keep track and watch as to the point that the scaling actually fits the map based on the texture that we're using, and still maintain the quality even using relatively small resolution textures. So just sort of keep that in mind as we move along. But I'm going to go through a process, an option here that is available as part of the tool set. But at this juncture here, we can more or less consider it's done if we're going to be putting on tileable textures onto our surface area here. Actually, let's see what happens. Now, things kind of explode when I kind of go off on a tangent here. So let's stay the course, and we'll assume that we can always demonstrate in another how-to of how to maintain tileable texturing and so forth. But we're just going to continue forward so we can sort of demonstrate a few more tools that are available in 3ds Max that allow you to create a finished terrain. So we'll just go ahead and consider this type of volume done. We'll hit the OK, and we'll do a convert to poly because we want to make sure that we have as much editable speed. And if we kind of look around, you can certainly see that our map is now distortion free using the Pelt mapper. And if I go back to, holy cow, we're up to 40 minutes so far, back to references, and we go back to X reference scenes here, and we turn back on our X reference, enabled our volume of space. Now we can go back and further optimize once, of course, our X reference objects are back into the scene here, and we'll just put that over to one side. That's the nicety of a dual monitor setup. All 3D graphic artists, dual monitors is almost a necessity nowadays, so we can move things around and off, and then we go back and optimize out that area that we did earlier to cut down as it's no longer really required. You probably want to do this if you're going to tile your texture after you've properly tiled your texture to decrease the amount of faces here. We're down to 6K now, or just under 7K, a lot more reasonable. Obviously we can refine and refine and refine until our surface area looks the way it's supposed to. Okay, so with that done, we no longer need this stuff here, so we'll disable our references, and that gives us our topology, our bucket for our map. Now we can more or less consider this done, and we can start moving off into different areas, like how we can use different techniques and different selections. Like for example, we want to have particular levels of details or differences in our surface area. We can certainly select this area here and throw a UV mapper on the stack, unwrap on the stack. Okay, we're just going to quickly demonstrate this. We can select a material type, apply that material to that surface area. I don't know how this is going to turn out. Boom. Okay, we'll kind of destroy things. We need to change the obviously need to change whoops, let's delete that. See, this is what happens when you go off on a tangent without preparation. You can see we have our selected ID. We need to change the ID to a different value, so we're texturing this with a different value that we can place onto that area there, a different texture, and then we can easily remap this area here based on the level of detail that we want, using either say for example a skin type texture, or to actually add in a different tiled type texture, and then start blending things into the various different areas based primary by changing or resetting our material ID. But we'll leave overall texturing of this for a different how-to. I was hoping to keep things down to a half an hour, but obviously we're going to be blowing that. But just at this juncture, I want to be able to demonstrate a tool that is now available in 3ds Max called the Viewport Canvas. Texture artists may probably not be comfortable with using this. They probably want to be able to use optimized techniques to create obviously what's going to be the ideal type of form and shape that's fitting of an urban terrain map. But it is an option that is available because it'll allow you to go in and create detailed areas that otherwise would be a lot more difficult to do using 2D applications like Photoshop to create say unique differences within our topology here. Of course, we're starting to ramble. I'm finding I'm starting to ramble on here a little bit, but this is pretty cool stuff. Anyways, just to kind of summarize a bit, we're done. We can deviate in all sorts of different directions to achieve a desirable final result. But carrying on here, we're going to use our viewport canvas here to actually help us paint out a distortion-free texture, and we do that by going to a different texture, tossing on. We're just going to toss on a simple texture here, because when we select the paintbrush in this mode here, it's going to ask us what type of surfaces that we want to paint onto. Now this is where things get a little bit more interesting, in that you can actually paint on things like bump maps and opacity maps and self-illumination and specular levels and so forth. So that's an option that is available for you. Even if you tile the surface, you can then create a overlay to that surface that is, once again, becomes tileable across the entire area. So you can create, for example, a bump map that fits in with the tileable surface that you actually have created. Do some detail work and so forth. But in this case, let's go ahead and create a diffused texture. I'm going to up this up to 2048. Once again, we're not locked into this type of texture measurement, as we can use various different techniques to sort of slice and dice and move things around. But for my purposes, I want to be able to create a topology, create a terrain quickly, so I can put it into Radiant and then out to the map, so I can visually see what is occurring. I want to be able to create in an hour a usable element, as even in a proxy type of position, so I can see it, how this is going to affect. Is it worth the effort to spend the hours and hours and hours of actually dialing things into perfection? So I'm just going to go ahead and create a 2048 by 2048. Oops, I have to obviously create a texture file that I want this to. I'm going to just drop this into any folder that first comes up and call it test, because I'm not going to be really using this texture for as completed as part of the demonstration of this technique. TGA image file, pretty well standard, or what we want to use for texturing. 24 bits, that's good, and we'll go ahead and go OK, and that will automatically set up our texture map, so it's used in the sampling slot here. So see, there's our texture material type, and it's using the test map that we've created. So now we're actually painting. We'll be painting on this surface area. Now, at this juncture, we probably want to see if we can try to refine the overall quality of the map by seeing what happens when we start doing things like clearing all and creating a different auto smooth map. Have we actually selected we haven't selected subsurfaces yet. We have to select polygon subsurface. We'll select all of the surfaces. Doesn't seem to want to select. Okay, there we go. Finally, see, things start to explode on you when you are recording. But we have selected surface areas. We'll do a clear all, do an auto smooth, and once auto smooth everything based on 1. So of course that is what we're going to go with. We can mess around once again for an extended period of time and trying to dial in the smoothing of the surface area. But moving forward, we'll go back to our viewport canvas, and as you can see, we can start painting directly onto the surface area. Now this is where the things start to get interesting, though, is when you start using custom brushes. Like there is 101 different ways and different things that you can do with the viewport canvas. Cut and paste various different elements and components onto the map quickly and easily in a distortion-free manner. But once again, that's another how-to video. So we're just going to go ahead and I'm going to take a look and see what some of the brushes that I have. I've just more or less converted over some interesting brushes that we can use here. And as you can see, as we paint along the surface, well, kind of looks distorted. That's because we are dragging behind. So we got to start looking at things like paint behavior, depth mirroring, how it's going to be painted onto the surface area. Also, the overall radius of the brush itself determines of how the texture is going to be laid down onto a three-dimensional surface versus a two-dimensional surface. That's something to keep in mind, because how this works is based on screen projection. So if we oversize our brush too much, the tendency will be to project our textures from the foreground into the background. So what we're going to land up with is a lot of stretching in our textures based on the angle and direction that we are going in. So for example, if I up the radius to a much larger brush, oh, don't explode on me please. Okay, there we go. You can see that how it's being projected at this particular angle based on surface deflection and texture projection. So in this case, our graphics tablet is more useful for doing finer details versus the ability of the mouse by just clicking on the surface area to actually push our texturing into the geometry based on hardness as well as opacity. So we want to make sure that our opacity is probably set to 0. No, and oops, in this case 100. And you probably want to play around with this value a little bit more to see just how much you can push into it, distort and create less distortion. So for example, with the hardness set to 100, you're going to get the full brush effect. And then we can just kind of move things around a little bit until our projection based on our present angle is equalized. And boom, we hit the mouse, click on the mouse button, and we're pushing in the texturing into the geometry. Now, as with Photoshop though, we can create and add layers. So we can do things like blending and so forth, and we don't have to worry about, okay, we got this really nice area in here, and we can go ahead and kind of protect it, particularly when we want to start going after areas that are distorted. We'll start with a relatively distortion-free texture map. Being aware of the direction of view that you're in. Beware that you are painting this as a projection. We're overlapping quite a few elements, but you can see how quickly we can create at least a base texture on a single sheet that we can then go in and use to examine in the game. Let's see if we can finish this under an hour. Okay, that's not too bad, but scaling wise it's probably a little bit larger. Okay, as we move away from the object, you can see that our projection is getting different. It's even covering a much larger area, so we can start thinking about at this juncture of creating a new layer and playing around with the opacity a little bit, so we can start blending in certain areas a little bit more by overlapping, so we don't get any seams. I'm not going to worry about too much about the smoothing groups at this stage, because this is more of a problem of the paint canvas than anything else. Okay, anyways, let's add a little bit of variety add to it. Just add a new layer on top of it. And obviously we have mask brushes that we can play with, so you can do some rather unusual things. But let's select a different type of brush. We've got a lot of grass here. Remember, the overall effect is projected based on the size of the brush. So we want to decrease the size of the brush so we can start putting in, say for example, some foliage in here. Stamp that in. You can see obviously it doesn't blend in well, so you probably can change the spacing and the scatter and so forth to click in on this layer here. Some roughage. This could be like trees that are falling down, so you can bake those right into the side. As you can see in the back here, obviously we got some distortion going on, but since that's not really facing the player at any given time, we don't have to worry too much about that. Okay, we got this nice little recess in here. We can put some paint in some junk there, or some little bit more rocky detail. A little bit more facial rock detail here. We need a little bit more blending to occur, so we can certainly select. Actually, we can do things like that we could do in Photoshop, like doing overlays and so forth, and hard lighting. Let's try a multiply. Multiply usually creates something interesting. Now, okay, dark. Now, okay. I'm not going to play with that too much. You can experiment on your own. So that's looking pretty good. A lot less distortion. You can see that because the UV map was stretched out based on equalization of the surface. This probably bugging people here, so let's go ahead and create another layer. Okay, we're closing in on the 1 hour mark, so we'll finish this up pretty soon. Opacity up, and we'll stamp that in. You can see the problem that you have with projection, and of course, once again, play with the opacity, hardness, so forth to kind of blend things in. This is kind of an ongoing battle over between the projection mode tendencies, but we can certainly fix this up in Photoshop. Photoshop is not out of the loop because you can go in and do a lot of the refinements. And let's go back and turn on and enable our reference models. Okay, we're going to flat and save the current texture, which saves it obviously to the texture file that we just created. Give it a second to decide it wants to make things visible. And of course, based on the overall lighting of our map here, we have to go in and do some magic things to our terrain. Okay, hold on. Where's our material type gone to? Okay, let's go to our material type and see. We're in a shaded view. Obviously, it's matching up. This will look how it looks like as how we painted it once we put it into the game. As reference to obviously to the buildings. I know how the buildings look like into the game, so we're okay with what looks like a little bit of oversaturation. So we'll leave it at that, and we're going to call our how-to here more or less done. While talking and presenting and basically messing up over the course of an hour here, you can see how easy it is to be able to create quickly a large area as opposed to focusing too much on isolated areas that we can use to tub in our map directly into our environment, in combination with the skybox that's going to be going around it. And then later on, if we wanted to, I could say, well, I can save this now out as an ASC, include it into my Radiant map, export it out, save it, compile it, and then examine it and see how does this actually fit. And we've done that. I can probably do this in the space of a half an hour, as opposed to having to do the same thing, fit to finish over hours and hours of work that may end up not looking the way that I wanted to. So at this stage here, we probably want to do an entire new how-to sections of how we can start to subdivide things out, how to apply tiling textures to optimize the effect, versus to how we actually know what this is going to look like inside of our map. And in my case, since Two Towers is going to be a rather dark map, the amount of texturing information that you're going to actually be able to see is decayed by the fact that this area here is a lot more about shadowing than it is about day glow neon texturing. Okay, there we go. 1 hour. We're done.